AP Calculus AB. AP Calculus BC, Unit 6, Day 11, Unit 6 Review, Extra Credit Review. Here are the answers if you need to check them real quick. This is the first page. Pause the video if you need to. Here is the second and third pages. Pause the video if you need to. And the last page is full-blown free response problem, so I'll just show you guys how to do that. All right, let's try these problems out. Preparation for our coming test. So match the slope fields to the differential equations. Take advantage of easy to identify slopes like 0 and undefined. Look for patterns. Use process of elimination. So this one just has a slope of -1 all the time. There's got to be a bunch of, I don't know. Slopes always, it's got to be a bunch of lines that look like this, right? Slope's -1, so that's going to be C. This one equals 0 when y equals 0, equals undefined when t equals 0. So y equals 0 is the horizontal axis. This kind of looks like that. Is there another one that's like that? These look like 0 slopes and 0 on both axes. So I mean, this one looks like it has 0 on the horizontal, 0 on the horizontal, but this is the only one with undefined on the vertical. So I think we got to go with B. This equals 0 when t equals 0 or y equals 0. So 0 is on the x and the y axis. So it looks like it's between these two. So that's enough. When t is positive, and well, it really just depends on y. When y is positive, you get positive slopes. And when y is negative, you get negative slopes. So I think we'll go with F there. This one, similar idea, t equals 0, y equals 0. So I'd probably go with D just by process of elimination, but let's make sure it makes sense. This one depends on the sign of t. When t is positive, they're all positive. When t is negative, they're all negative. So yeah, that's D. I don't think this is ever going to be 0 unless t is 0 and y is 0 at the same time, but that's only time. These are definitely going to be positive slopes the whole graph. So that gets rid of C and E. It's got to be A. Positive graphs the whole way. The only 0 slope is right at the origin when t equals 0 and y equals 0 at the same time. This one equals 0 when t equals 0, so that's the vertical axis has zeros, but so did this one, and so did this one. But I guess there's no undefined slopes, so, and there's no other 0 slopes, so that would get that one out, and that would get that one out. So it's got to be E. There you go. All right. So you should have some kind of work, label things, circle things, show little things here. Next one is, let's see, estimate using Euler's method. So Euler's method takes the slope of, it takes an equation of tangent line and makes an estimate. It's tangent line approximation, but repeated. So this is y new, x new. So y new equals y old plus y prime old delta x. So you can set up the table like that. Start with the initial condition, 110. Step size is 0.5 to get to 3. Don't need the last one. The last one will be our last one. So it's going to be this plus this times this. That comes from that basic equation of line. So we got to calculate the slope. 4 times x times 10, that's 40. It's going to be this plus this times this, so that's going to be 30. And it's going to be 4 times out 6, that's going to be 180. So it's going to be this plus this times this. So that's going to be 120. So it's going to be 8 times that, that's going to be 960. Wow, I'm getting some big slopes here. It's going to be 480. It's going to be 600. This is going to be 6,000. It's going to be 3,600. So let's write your answer nicely. F3 is approximately 3,600. So you do it. B, find the actual value. Well, actual value would be solving the differential equation. So we're going to separate the variables. Integrate both sides. Plus C. Use initial condition. C equals natural log of 10 minus 2. Rewrite it. Natural log of the absolute value of y equals 2x squared plus natural log of 10 minus 2. Exponentiate both sides. Get rid of the absolute value by doing plus or minus. Now I'm going to move this 10 out in front, and then e to the 2x squared minus 2 is all. I'm just going to leave that all together. So I'm using rules of exponents. Hopefully you guys follow that. Algebra 1 stuff. You got to choose as positive or negative. You plug 1 in, you get e to the 0 is 1, times 10 is 10. You want it to be positive based off the initial condition. We've seen plenty that have turned out to need the negative. Now, are there any issues here with domain? Nope, nope, nope. So for the domain, infinity, positive infinity. Now, we're using this to calculate 3. So we plug 3 in here, and we get e to the 18 minus 2 is 16. And so I'm going to use my calculator to just get the exact answer so I can compare it to 3,600 better. So it's going to be 10 e to the 16. Oh, God. 888,611,05.21. Yo, this is 88 million. Not very close. I guess we should do more steps, smaller steps. All right. And we got some more solving differential equations, which is part 2 mostly. You guys should be getting the hang of these. Pretty much calculate V problems unless some new integration techniques come in. So separate the variables. Integrate both sides. Plug in the initial condition. Find C. Rewrite your equation with your C value in it. Solve for Y. Take the natural log of both sides. Divide both sides by 2. So that's what we got. We need to check out domain. Domain here, can e to the 2y ever equal 0? Can't happen, doesn't happen. Don't worry about it. This, the inside of a log needs to be positive. But let's just set it equal to 0. And solve. x equals the negative cube root of e over 2. So do a quick number line, put an open dot there. Now we gotta estimate this. This is about 1, negative 1. The initial value of 0 is clearly to the right. It's for sure negative. So that's your domain. So we're going to write y equals 1/2 natural log of 2x cubed plus e for the domain negative cube root of e over 2 to positive infinity. Got to include the domain. It's part of the answer. Okay, number 9. Separate the variables. It's pretty much already done. Integrate both sides. Plus c. Use the initial condition. Natural log puzzle 1 is 0. C equals 2. Rewrite it. For sure, we're going to be able to get rid of that absolute value because it's going to cause problems. In the domain, this is all reals, but here, x can't equal 0. So x can't equal 0. Your initial condition's at negative 1. This is your domain, which means you're for sure plugging negatives in. So your final answer, we can drop the absolute value and put in negative x. That will do the same thing as an absolute value of a negative. You just use negative, change sign. For the domain, negative infinity to 0. There you go. Next one, separate the variables. Not very hard to separate the variables. Integrate both sides. Y equals natural log the absolute value of 2 minus x. You need an extra negative in front because of this negative, because chain rule. Don't forget that. So plug in the initial condition. Natural log of 1 is 0. So c equals 0. So we rewrite it. Y equals negative natural log of the absolute value of 2 minus x. Guarantee you can write this without the absolute value because that's causing a problem. Here it's all reals, no problem. Except for 2. Here x cannot equal 2 because that would be natural log of 0. Here though, x cannot equal 2 also. So put that in line. Initial condition is at 1, which is for sure to the right. And so we're going to always be putting numbers bigger than 2 in, which means this is going to be negative for sure. Which means we could do an extra negative to get rid of the absolute value. We could write that a little nicer, probably. Negative 2 plus x. Did I do that right? Oh, shoot. No. 1 is over here. So you're for sure going to be plugging a number smaller than 2, which means this is always going to be positive, so you can just drop the absolute values. All right, so final answer is y equals negative natural log of 2 minus x. If you really want, you can write this as natural log of 1 over 2 minus x if you want to bring that in. For the domain, negative infinity to 2. All right, let's keep going. Separate the variables. Right away, I'm thinking, you know what? I bet this is integration by parts because I don't think I can integrate x over e to the x. So I'll probably go do lipit. And it is poly expo. So we could do the shortcut. So derivative of x is 1, derivative of 1 is 0, negative e to the negative x, e to the negative x, antiderivatives, positive, negative, positive, multiply through by diagonals. So it's going to be natural log the absolute value of y equals negative x over e to the x minus 1 over e to the x plus c. Plug in the initial condition. That's going to be 0. This is not going to be 0. That's going to be 1. So c equals natural log of 2 plus 1. So we're going to rewrite it. Natural log of the absolute value of y equals negative x minus 1 over e to the x plus natural log of 2 plus 1. Exponentiate both sides. Get rid of the absolute value, plus or minus. Now e to the natural log of 2 is 2. So it's going to be e to the negative x minus 1 plus e to the x. If you want to put this all in one big crazy fraction, that's all in the exponent too. Is it positive or negative? Plug 0 in. We get e to 0 is 1, is 2, it needs to be positive. Now, e restrictions? No problem there. E to the x can't be 0. This can have division by 0, which is fine. I think there's no issues. 2e to the negative x minus 1 plus e to the x all over e to the x. For the domain, negative infinity, positive infinity. All right. Get the hang of them. Here's a couple good ones for various reasons. All right. To separate the variables, you got to factor the y out. So then it's going to be y dy equals 1 over x plus 2 dx. We're going to integrate both sides. It's going to be y squared over 2 equals natural log of the absolute value of x plus 2 plus c, use the initial condition. Negative 4 in for the y. Negative 1 in for the x. Natural log of 1 is 0. C equals 8. And rewrite it. Y squared over 2 equals natural log of the absolute value of x plus 2 plus 8. Multiply both sides by 2. Y squared equals 2 natural log of the absolute value of x plus 2 plus 16. You can take the square root of both sides. Plus or minus should be in your work. Is it positive or negative? It's the negative. To give you a negative 4, we're going to plug in negative 1. Natural log is going to be square root of 16 is 4. It's got to be negative. Got to go with the negative. Now, there's two issues. There's multiple issues here for domain. Here, x cannot equal negative 2. Here also, x cannot equal negative 2. Y can't equal 0. The inside of this has to be greater than or equal to 0, which is going to come from the same thing as saying y equal to 0. So we got to solve this. Natural log of x plus 2 equals negative 16 over 2. Exponentiate both sides. Get rid of the absolute values, plus or minus. So this is going to be e to the negative 8th plus or minus. Subtract 2. So one of these values that are bad is negative 2 plus 1 over e to the 8th. And then the other one is negative 2 minus 1 over e to the 8th. So we have a bunch of different values. So if we do a little line thing here, open circle negative 2, this is a little bigger than negative 2. This is a little smaller than negative 2. You just got to get them in the right place, left to right. And then this is pretty much just almost negative 2. So negative 1 is for sure over here for the open interval for the domain. So that's your domain. So your final answer, now by the way, we're plugging numbers in that are for sure bigger than negative 2. So that's always going to be positive. So we can drop those absolute values. So y equals square root of 2 natural log of parentheses x plus 2 plus 16 for the domain parentheses negative 2 plus 1 over e to the 8th, comma, positive infinity. There you go. All right, number 13, You might be tempted to think of this as logistic, but logistic is ky n minus y, and you can get this to be pretty close to it. Y times 1 plus y. So you go, oh, here's your k, and here's your m. There's one problem. This is a minus, and this is a plus, so it's not logistic. And even if it was logistic, you'd only get max half credit if you took the shortcut, but it is not logistic. And you need to do it the long way to get full credit on part 2. So let's see if we can do it. I've done it a few times. It's not super easy, but we got to separate the variables. The factor version is probably the best. Then you got to integrate both sides. So here we got to do partial fractions: a over y, b over 1 plus y. So if you multiply through by the least common denominator, plug 0 in, a equals 1, plug negative 1 in, b equals negative 1. Okay, rewrite it. 1 over y minus 1 over 1 plus y, dy dx. So let's integrate both sides. Natural log of the absolute value of y minus natural log of the absolute value of 1 plus y equals x plus c. I'm going to clean this up, combine these together. And then let's use the initial condition. And c equals natural log of 2. So we're going to rewrite it. Natural log of the absolute value of y over 1 plus y equals x plus natural log of 2. We are going to exponentiate both sides. We could then get rid of the absolute values by doing plus or minus. There's going to be 2 in front, e to the x. Rules of exponents is the same thing as e to the x times e to the natural log of 2, and e to the natural log of 2 is 2. We're going to multiply. Now we got to decide is positive or negative. If you plug in 0, you get 2. Plug in y, so it's supposed to be negative 2 over negative 1. It's the positive. So then we're going to multiply both sides by 1 plus y. So we get y equals 2e to the x plus 2e to the xy. So we're going to bring the y's back over on the same side. And factor out the y, divide by the coefficient. So y equals 2e to the x over 1 minus 2e to the x. Now we got to look at domain. There's no domain in the original derivative. But here, this can't equal 0. So let's set it equal 0 and solve. So you can natural log both sides. So on number line, natural log 1/2. Natural log 1/2 is a positive or negative. It's negative. So x equals 0 is for sure to the right of it. For your single open interval, for your domain, for the solution of differential equation. So your final answer is y equals 2e to the x, 1 minus 2e to the x for the domain. Natural log of 1/2 to positive infinity. Got it. Okay, you can do it. You can do it. Even if it's logistic, you could do it. I mean, it's stuff you're supposed to be good at anyways from before this chapter, right? I mean, this doesn't really involve anything new from this chapter. It involves AB skills and stuff from first semester. All right, let's take a look. Problem on the back. Okay, for your response problem. Differential equation, which by the way, ky a minus y, this is logistic. Usually they tell you somewhere that it is logistic, but I don't know, maybe this time they don't. Okay. Initial condition, slope field, sketch possible solution for 3, 2, which is right there, 3, 2. So even without knowing this, without knowing it's logistic, you should hopefully realize there are horizontal asymptotes that's going towards arrows in the ends. So, okay, that looks like a logistic curve. 0,8's up here. And this one is kind of interesting. It kind of looks like a decay function. And it's sort of outside of where we usually think of logistic functions, but there are solutions above and below the normal section of logistics. So it really just depends on the initial condition. B, use Euler's method at time 0 with 2 steps at equal size. So there's 2 ways to do that. And it's 2 step size, so it's not too crazy. We say, okay, well, y minus y1 equals m times x minus x1 is the equation of a line. This is like some previously known x and y, which I'm going to call old. We're trying to find a new one. And this is going to be y prime. So y new equals y old plus y prime delta x. So you can do the table. I guess I'll start with that. I'll show the other way also. But I think going through this and writing this out is critical. We're starting initial condition 0, 8. 2 steps at equal size to get to 1, which means they got to be 0.5 each. It's going to be this plus this times this. So y prime, we got to use dy dx equals y over 8, 6 minus y. So we got to plug 8 in here. That's going to be negative 2. So it's going to be this plus this times this. So it's going to be 7. Then you got to plug 7 in here, and it's going to be negative 7/8. Right? It's going to be that plus that. So that's going to be negative 7/16. So it's going to be 6 and 9/16. So f of 1 is approximately 6 and 9/16. Or you can just write the equations of the tangent lines yourself. It'd be the same work. I feel like the table pays off when there's a lot more steps. These aren't that many steps. So you do y minus 8 equals, I should probably find the derivative first, dy dx at 0, 8 is going to be 8 over 8. 6 minus 8 is going to be negative 2. So slope's negative 2, x minus 0, y equals negative 2x plus 8. That's the equation of your tangent line. So then f of 0.5 is approximately negative 2 times 0.5 plus 8 equals 7. So f of 0.5 is approximately 7. Same answer we got in the table. Then we do it again. Y minus, well, we should probably find dy dx first. dy dx at 0.5 comma 7 is going to be 7 over 8. 6 minus 7, negative 7/8. So y minus 7 equals negative 7/8. X minus 0.5. So you can get y equals negative 7/8 x plus 7/16 plus 7. That's your equation of your tangent line. So f of 1 is approximately negative 7/8. 1 plus 7/16. Least common denominator is going to be 16. So it's going to be minus 14/16. So you're going to get take away 6 and 9/16. So f of 1 is approximately 6 and 9/16. I mean, you write it as just one big number too if you want. What would it be? 636, 645/16. No, 96. 105. 105. All right, that's Euler's method, multiple tangent line approximation. C, find the particular solution for the given differential equation. Well, this is where I already told you it was logistic, right? So I think it's totally cool. Ky minus y f 0 equals 8. So I think we should definitely use our memorized result of y equals m over 1 plus a e to the negative mkt. And you got k and you got m. So we got 6 over 1 plus a e to the negative 6 times 1/8 t. You plug in the initial condition times 0. You can find the a value pretty easily. That's why I told you not to memorize that. If you do, taking off points. Now m is 6, right? 8a equals -2, a equals -1/4, right? So your answer is y equals 6 over 1 minus 1/4 e to the -3/4 t. I don't really want fractions and fractions, so I think we should clean that up. Multiply by 4, y equals 24 over 4 minus e to the -3/4 t. For the domain, this is a solution of differential equation, right? This has issues. This one has issues because, by the way, this solution is this one up here. So it's not normal. So for domain, no issues there, but 4 minus e to the -3/4 t cannot equal 0. And it looks like it could. Natural log both sides. Multiply both sides by 4/3. Now, on a number line, this is negative. Natural log 1/4 is negative. So 0 is for sure to the right. So that's your slope. So for the domain, 4/3 natural log of 1/4 to positive infinity is your proper answer. Yeah, okay. It says part D, what is the range for your answer for t greater than 0? Well, I mean, based off the graph, I don't know. This is negative, right? So they're saying that t has to be greater than 0 for part D. The easiest way is to look at the picture. Look at your sketch. This is it right there. 6 to 8. Range is 6 to 8, including 8, not including 6, because 6 is the horizontal asymptote. I mean, that's the easy way to go. Otherwise, you could plug 0 into your answer, right? Which gives you the 8. Take the limit of y as t goes to infinity. See what happens as t gets bigger. I mean, we could totally do it this way. But I like that looking at the picture approach. As t goes to infinity, this goes to 0, and it goes to 6. Never gets there. It gets closer and closer to it. So this might lead you towards the same conclusion. Definitely matches the graph. That's it.